Rift is several miles long, and some believe it is a sign the continent is splitting in two.
Two sections of Africa, of the continent, have started to move apart, and this change is associated with the East African Rift system.
In the heart of East Africa, where the Earth's crust bears ancient scars and tells stories written over millions of years, a colossal transformation is underway. A new ocean is being born, and the African continent is undergoing a split so immense that it will eventually reshape the map of the world. Deep within the arid landscapes of Ethiopia's Afar region, a massive rift has been forming, one that may eventually separate the eastern portion of Africa from the rest of the continent. This isn't science fiction or a distant geological myth. It is a slow, powerful geological process happening right now beneath our feet, and scientists have finally confirmed the reality. Africa is splitting into two continents. Before we start, smash the like and subscribe buttons for more updates. The East African Rift System, stretching more than 3,000 kilometers from the Red Sea down through Mozambique, is the visible sign of this monumental event. It is a place where tectonic plates, the vast mobile segments of the Earth's lithosphere, are pulling away from each other. The African plate is dividing into two parts, the larger Nubian plate to the west and the smaller Somali plate to the east. This slow-motion disintegration is not only a stunning reminder of Earth's dynamic nature, but also a precursor to a new ocean that will eventually form between these two landmasses. Evidence for this separation has been accumulating for decades, but it's only in recent years, with the aid of satellite technology, seismic data, and advanced geological modeling, that the full scale and inevitability of the split have become clear. In 2005, a dramatic sign of this activity surfaced in Ethiopia when a 60-kilometer-long crack tore open the desert in just a matter of days. This massive fissure in the earth, created by volcanic activity and tectonic movement, offered a preview of the forces shaping the future of Africa. Since then, further fractures have emerged, steadily expanding year after year. Beneath the rift, magma pushes upward from the Earth's mantle, weakening the crust and forming new geological boundaries. These rifting events are not random, but follow a clear pattern of tectonic divergence. As magma wells up, it not only fuels volcanoes scattered throughout the region, but also acts as the driver of the continental split. The process is known as continental rifting, and while it has happened before in Earth's history, most notably with the breakup of the supercontinent Pangaea, it is rarely witnessed with such clarity in the present day. What makes this situation even more fascinating is the speed at which it is happening, at least in geological terms. Typically, tectonic shifts occur at a rate of a few millimeters per year, a pace almost imperceptible to human observation. However, in parts of the East African Rift, scientists have recorded movement rates of up to 7 millimeters annually. These numbers, while still slow compared to everyday human experiences, signal a dramatic pace for geological transformations. One of the most striking features of this tectonic evolution is the formation of new land features. Vast valleys, deep cracks, and chains of volcanoes, many of them still active, line the rift zone. Over time, as the crust continues to thin and pull apart, these features will evolve further. In the distant future, perhaps tens of millions of years from now, the rift will be flooded by seawater, forming a new ocean and permanently dividing Africa into two separate continents. What we now know as Ethiopia, Kenya, Tanzania, and other nations along the rift's path will become part of an entirely new continental mass. This immense geological shift carries with it profound implications, not just for geography, but also for ecology, climate, and human settlement. The East African Rift Valley is home to millions of people and a stunning diversity of ecosystems, from lush highlands to parched deserts. As the rift widens and the land continues to subside, communities may face increasing risks from earthquakes, volcanic eruptions, and changes to water systems. Lakes such as Tanganyika and Malawi, which already sit within the rift, are among the deepest in the world and may expand as the rift opens further. In terms of biodiversity, the region's unique evolutionary landscape could be significantly altered. The East African Rift has long been a cradle of life, giving rise to species found nowhere else on Earth. As the land divides and climates shift, habitats may be fragmented or lost, putting endemic species at risk. Yet at the same time, new ecological niches may form, potentially driving evolutionary change in unexpected ways. This duality, the simultaneous destruction and creation of environments, is a hallmark of geological transformation on such a massive scale. The human dimension cannot be overlooked. The areas surrounding the rift are already vulnerable to natural hazards, and the progression of the tectonic split will only increase these risks. Earthquakes are becoming more frequent and intense in parts of the rift, a result of the immense stress being applied to the Earth's crust. Volcanic eruptions like those from Mount Nyiragongo and Mount Erta Ale could also become more common, posing direct threats to nearby populations. Infrastructure, agriculture, and urban development may all need to adapt to a shifting and unstable ground beneath them. From a scientific standpoint, the rifting of Africa presents a rare opportunity to study continental breakup in real time. Most of our understanding of such events comes from ancient records preserved in rocks, or from oceanic rifts that are difficult to access. In contrast, the East African Rift offers a terrestrial laboratory where researchers can observe the mechanics of plate tectonics, volcanism, and seismicity as they unfold. Every tremor, every crack, and every outflow of magma adds to our understanding of how continents form, move, and eventually break apart. The implications stretch beyond Africa as well. Understanding the mechanisms behind continental rifting can shed light on similar geological settings around the globe, from the Great Basin in North America to the Baikal Rift in Russia. The East African Rift, with its unique clarity and scale, serves as a reference point for these studies. It challenges existing theories, invites new hypotheses, and provides critical data that help refine global tectonic models. There is also an important economic and geopolitical dimension to consider. The rift is rich in geothermal energy potential, thanks to the high heat flow from below the Earth's crust. Countries like Kenya and Ethiopia are already harnessing this resource, generating electricity from geothermal plants that tap into underground reservoirs. As the rifting continues and the Earth's crust thins further, these resources may become even more accessible. At the same time, mineral deposits associated with volcanic activity, such as rare earth elements, may become more abundant, drawing investment and competition. However, the extraction and use of these resources must be approached with caution. The rift zone is a delicate and often volatile environment. Mismanagement could exacerbate environmental degradation or trigger further seismic activity. Balancing development with conservation and safety will be crucial in navigating the future of this region. Scientists, engineers, and policymakers will all play a role in ensuring that the benefits of the rift's transformation are realized without compromising the well-being of those who live there. Looking deeper into the geological story, the origins of this rift lie in the complex interactions between Earth's internal forces. The mantle plume theory offers one possible explanation. According to this idea, a giant column of hot material rises from deep within the Earth, weakening the lithosphere above and initiating rifting. In East Africa, such a plume may lie beneath the Afar region, creating the high heat flow and volcanic activity observed there. This theory is supported by the unusual topography and seismic behavior of the area, including frequent tremors and high rates of crustal thinning. Another explanation involves stresses from neighboring tectonic plates. The Red Sea Rift to the northeast and the East African Rift are part of a broader tectonic system driven by the movement of the Arabian, Indian, and African plates. The separation of these plates creates pull-apart forces that stretch and fracture the Earth's surface. Over millions of years, this process weakens the crust, forming faults and rift valleys that eventually evolve into new plate boundaries. Whichever forces are most responsible, the outcome is clear. A dramatic geological reconfiguration is taking place. This is not a static event, nor is it a singular moment in time. It is a living process, unfolding over millennia, driven by heat, pressure, and the restless dynamism of Earth's interior. What makes the East African Rift particularly compelling is its visibility. Unlike oceanic rifting, which often occurs thousands of meters below the sea surface, the African split is happening in plain sight, across populated regions and accessible terrains. One of the most visually stunning manifestations of this process is the Afar Triangle. Located at the junction of the Red Sea Rift, the Gulf of Aden Rift, and the East African Rift, this region is a geological crossroads. It is a place where the Earth's crust is so thin and stretched that one can see deep fissures slicing through the landscape. Volcanic cones rise in surreal formations, and lava lakes bubble within massive calderas. It is here, at this tectonic triple junction, that the earliest stages of ocean formation can be observed. One day, this region may lie beneath the waves, a submerged reminder of Earth's endless transformation. Even now, signs of that future ocean are emerging. Subsurface imaging has revealed magma chambers forming along linear rift segments, precursors to mid-ocean ridges. These ridges, once fully developed, will produce new oceanic crust as magma solidifies at the rift's center. Over millions of years, seawater from the Red Sea and the Indian Ocean will flood the deepening rift valley, forming a new seaway. What is now dry land will become ocean floor, teeming with life adapted to a submarine world. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Africa splitting into two continents? We want to hear from you. Thank you for watching and see you next time.